to see, go over, have questions about 2, 1,
4.
4. Any others? Sure. Alright, so starting with number 1, you have a vertical line. So if you weren't thinking this, you probably should have been. Vertical line, it would be an x equals, what's your slope? Oh,
0. No.
I called it long line, but it's not my fault. The vertical line,
Oh, it's
the
undefined.
equation would be x equals 1, but yes, the slope is undefined. For number 2, it's asking, do these ordered pairs make this a function? If your x's, any of your x's repeated and had different y values, so like 1, 3, and 1, 2, then it would not be a function. Here we have different x values that go to the same y value, but that's okay. So this is a function. Questions on either of those? Or we have to find the domain and range. Because this is a discrete function, not continuous, they're not connected, we have to list them least to greatest. Domain is your x values, so -4, -2, -1, 1, 3. And you would list them out without any repeats. Then your range, you would also list out lowest to highest without repeats, but y values, so -4, 2, 3, 4. So even though there are 2 points at y equals 2, we only list it once. Questions on that? Then number 5 is asking how many solutions does this have? So without doing the work, we can figure out this answer, but then we'll also figure out the answer with doing the work. If you remember that these are not identical, they're not the same, so this cannot be infinitely many. The coefficients are not the same. We do have different constants, but not the same coefficient, so it can't be no solution. So it would have to be 1. So you can do that without doing work, or you can do it with work. And solve for x. I would subtract 5x on both sides, subtract 10 on both sides. We have x equals -13. Which would also show you have one solution. Questions on that? Before we get into today's lesson, look at your course calendar. There's a few things I wanted to mention. First, you'll notice that today's date and Tuesday's date both have the same Khan Academy quiz date, which means the ones from today that you'll be able to do after you do today and the ones from Tuesday will all be due on Friday. I would highly advise / recommend that you do the ones from today, so you're not overwhelmed when you see 5 due next week. There will be 3, there's 3 up already. That will be on what we learned today, and 2 more that will open on Tuesday. Then next Thursday is your flex day. We already did 2 flex days in February, which is why we had to move it to March. for those of you who need to finish your tests, I'm in the process of still grading those, but for those of you who need to finish, Thursday you can do that, but I wouldn't wait until then. I would come see me as soon as possible. You may have time today also to do that. The next 3 Fridays you will have Khan Academy quizzes, so make sure you're on top of those. The 14th is our second flex day in March. The 16th is your quiz. The 20th is your test. So those of you who need to finish Unit 6 tests will have to have them finished by the morning of our test, because that would be the last time you could come to me to get it done. Right? Keep those dates in mind. Also, the end of the quarter is the 31st of March. So this will be the last thing that goes in Marking Period 3. I know it's really short time turnaround from when you guys take the test, so I'll try and get those graded as soon as possible so you can get it back. So if you need to retake, you will have like a week-ish to do that. But the cutoff date will still be the cutoff date because spring break will be after that. Okay? Questions on any of that? Okay. So everyone should have these notes in front of them. As I always say, try to do better this unit. If you didn't pay attention well last unit, do better. If you were on your phone a lot last unit, do better. If you slept a lot, do better. Pay attention more, ask questions more, participate more, all those things. So this unit is all about quadratics. So we dabbled with quadratics a little bit last unit, but we didn't actually say those words. Factoring usually is with quadratics. So we were just finding factors of quadratics. We weren't doing much more with it. We are only going to cover some of the ways you solve. There are more than what we're going to do. The ones we don't do, you'll cover in Algebra 2. Okay, so the first way to solve a quadratic is using square roots. You'll be given something that looks like this, where instead of like our trinomials where we had ax squared plus bx plus c, we're missing that middle term. So we might have more than this, less than this, but if we have more, they're just going to be similar, like another x squared term or another constant, and we have to combine like terms. So our goal is to get x by itself, find the roots or the solutions. So here are our steps. Isolate x squared. What does that mean? What do you say? Get it alone. Mm-hmm. So get x squared by itself. Correct. So we will add 49 to both sides. And then take the square root of both sides. Which would give you 7. Except, we know that it'll equal a positive 7. And we also know that 2 negatives multiplied together gives you a positive. So we have to take into account both the positive and the negative. We're going to put plus or minus 7 to say the negative and the positive. But then we have to write it a specific way in set notation. So you can write that one of 2 ways. In curly brackets, plus or minus 7. Or separated, negative 7, 7. If you separate it, the lowest always has to go first. It's least to greatest. Questions about this process so far? Some of you may remember from the variations test where there was a problem. You took the square root of something and got, one of the answers was plus or minus 5. That was like a head start on this. So then for number 1, how would we solve that?
So plus 16.
Mm-hmm. Then take the square root of both sides.
4.
So we have plus or minus 4. I'm going to write this both ways, but you don't need to write it both ways. Pick whichever one you like better. So mine aren't the best. It can't be a square bracket, no. It has to be curly brackets.
So how would we show that, for example, like on decimals?
Like the answer? I'm going to show you later. How would we do the next one?
Plus 100.
Mm-hmm. Then we take the square root of both sides. What would that give us?
10.
Plus or minus 10. If you don't have your calculator, I would suggest going to get it. Now let's see what happens when we do 3. Here now we're adding instead of subtracting, so we would subtract 25. What happens when we take the square root of negative 25? And if you're not sure where the square root is, it's in blue above x squared, so second x squared will get you there.
Would it be undefined?
Yeah, yes, no, it's like it's undefined, but not at the same time. Here we're going to put no solution. So in this class, we will not be able to solve when you have a negative underneath. In Algebra 2, you will go on to do that with imaginary numbers. You would just put no solution. This is the only one that does not need curly brackets. Then you'll have some that aren't equal to 0, but you would do the same thing. So we can, if you wanted to make it equal to 0, you could move it, but then you would just have to move it again, so I'm not doing that. Subtract 7 on both sides. Mm-hmm. So when we subtract 7, we get what?
81. And the square root of 9.
Plus or minus. So I'm saying or, but it's really and. It's both. Negative 9 and 9. It's just how the symbol is read. Plus or minus. Plus or minus. Okay, let's do the next one. Subtract 7. We get negative 3. We take the square root of both sides. What would that be?
0. No solution.
No solution. So always, even if you think it's going to be no solution, keep going. Isolate the x squared. Sorry. Because it could start off not looking like you need to, or not looking like it's going to be no solution, and then end up becoming that, or vice versa. Alright, let's do this next one. Add 5 to both sides. What do we get there?
1.
So what would that solution be?
1.
Plus or minus?
Plus
Both. No, it's both. This is read as plus or minus. It's not undefined. It's no solution. doesn't work. You get a non-real answer. Means you have to wait till you get a imaginary numbers. Let's skip to 9. How would we solve that?
Would it be multiplied by the reciprocal?
Take this, flip it, multiply that on both sides. The 3/4 and the 4/3 cancel. What would that equal?
X squared equals 16.
And then take the square root of both sides. What would that equal?
4.
Plus or minus 4. Yes, it's both. Or you can write it as two separate things. -4 and +4. But it means both. Even though it's read as plus or minus. What about 10? How would we solve that? You could do that. I wouldn't recommend doing that first. So add 5, yes.
And then is it multiplied by the reciprocal?
Now we can multiply, yes. We have x squared equals 100. We take the square root of both sides. What would that be? Plus or minus? You guys are going to get annoyed of that. But if you don't put that, you're going to miss points. Because you need to have both. We're going to do some on the back, but before we do that, are there any that we missed or skipped over that we want to see? Go back over, do. Eva, these notes are on canvas. 8, yes. So Jade, you should probably be writing this down. 8, how would we solve this?
Divide negative 2 over 7.
What would that give us?
49.
So then if we take the square root of both sides, that would be plus or minus. It'll be annoying, but it'll help you remember. Okay. Go on to the next page. Let's jump down to 16.
Plus 16 first.
And then?
Divide 9.
Yeah.
Okay. If you can simplify, try and do that. If not,
3, it's the denominator is 3.
yeah. So when you take the square root of a fraction, you're really taking the square root of each of these individually if they're perfect squares. So you could think about this like the square root of 16 over the square root of 9. So what would that be?
Plus or minus 4/3.
Okay. So some of your answers may be fractions. Some you may do accidentally and get a fraction. So double check your math. Questions so far? Let's do the next one.
4/3. So this seems a little way too easy.
That's good. It should feel
What's the
easy.
catch?
There's no. I promise there's no.
There's no catch. Okay.
There's no catch. You'll get fractions and decimals. Be okay with that. That's your catch. That's it. Okay. 17. How would we do that?
Plus 1.
both sides, what would that be?
Also minus pi over 2.
Yes, because these are both perfect squares. Okay, then we're going to do 18 and jump to some where they aren't perfect squares, but it's going to be very similar. Alright, so for this one, subtract 16. Divide both sides by 49. What would that solution be?
Would it be no solution?
It would be no solution. Not because 8 is not a perfect square, but because it's negative. Now, in Algebra 2, you'll learn how to simplify radicals. We're not doing that. So we're just going to get decimals.
Do we round it?
Yeah, we'll run. So in 19, it's already isolated, so take the square root of both sides. I would say put 2 to 3 decimals. 2 is fine, 3 is great, more than that is awesome, less than that is not okay. So 2 to 3 decimals.
But if we can round it, we just do 1.
Round to 2 or 3 decimals. So the square root of 19 is
4.35889.
we do 4.359, 4.36, either of those. Okay. So always, if you're not sure, always do the square root of whatever the number is. If you get a whole number, great. If you get a decimal, it's fine. Just still write it up. So 20, we would do what?
Add 41.
Take the square root of both sides. What would that give us?
6 plus or minus 6.403.
And let's do another one like that. We're going to skip 21, jump to 22. How would we solve that?
That's 126. Divide by 2.
When we divide, we get what?
63.
We take the square root of both sides. What would that give us?
7 plus or minus
7.937.
937.
Once you have that written down, look at numbers 23 through 30. Of those, which ones do we want to see, go over? They look challenging. You're not sure how to start it, anything like that.
27.
Been popular today.
I mean, yeah, that's the only one that has parentheses.
Okay. Any others? 30. Okay, let's do those 3. Starting with 25, what would we do first?
Minus 2.
And then
We multiply by the reciprocal.
take it, flip it, multiply by 3 on both sides. So if we take the square root of both sides, what would that give us?
36? Yeah, x squared equals 36.
The square root of 36.
Oh,
But plus or minus. 27. What do we suggest to do first for that?
Distribute. No?
Okay, we could do that. We will do that
unless it's
Multiply the 3
by reciprocal. So I'll show you what will happen if we distribute after we do 30.
which is the right way though?
Both are right. One is probably less desirable, is all. Okay, so if we multiply by 4/3 on both sides, I didn't do that. The 1 would cancel. The parentheses get dropped down, or disappear. You know what I'm saying? What would this be? And then we don't have fractions, so we can solve it like normal. Add 17 to both sides. Take the square root of both sides.
Plus or minus. Plus or minus.
So I'll do that. Distributing in 1 second.
So it is better to do it to multiply by 6.
Yeah, that's my go-to, but that's not the only way. Okay, for 30, how would we do that?
In this time?
I don't know why I put 35. I meant 25. Anyway.
Divide by, what is it, 25?
Take the square root of both sides. What would that give us?
6 over
Plus or minus 6 over 5, yes. For some of those, if you were just putting it into the calculator, maybe not as a fraction, maybe as a fraction, doesn't matter. And you get a decimal. If it's a nice decimal, you can leave it. But notice that you could have also just taken the square root of both the numerator and the denominator. So I'm going to rewrite 27 down here. So you see what happens if we were to distribute first. Okay, so if we distribute, we have 3/4 of x squared minus, what would that number be? Leave it as a fraction.
51 over 4.
So already not looking nice.
And then plus
51 over 4 to both sides.
uh, 75 over 4.
Then we still have to take this and flip it and multiply it. Fours would cancel. 75 divided by 3 would give us 25, and then the rest would be the same. So you could do it that way.
No, that's too extra.
That's what I thought.
Yeah, that's
Okay. Any others we want to see go over how questions are? So I would say you have time to get all 3 of the ones that are open, that are due next week, done today. I'm here. You can ask me for questions, get my help. I would say it's hard to see because the title's so long, but I would do it in this order because it gets progressively harder for each one. I would do steps first, so you may have to click into it and see which one it does. And then strategy, and then intro. Steps is like, it has the problem, it has all the steps listed for you, you just have to put them in order. Strategy is, it has some of the steps and you're trying to figure out where they went wrong. And then intro is you solving it all together and you finding the answers. So I would do it in that order, that way you kind of see the buildup of those. Let me know if you have questions. If you need to finish your test after you've done your Khan Academy, you can come see me to do that. If you don't need to finish your test, you can work on more practice on this stuff. Use this time wisely.